Hey guys, welcome back. The algebra teachers are hoping that we can use this new platform to try to review some of the current information that we recently covered, as well as eventually going on and learning some new material. So we hope that you're doing well at home, and if you have any questions at any time, please feel free to either email myself, Mrs. Klemick, or Mrs. Nicholson, or Mrs. Rowley. Okay, so today we're going to do a review of exponent properties. Okay, so the first one we learned is that the product of powers property, and this should be pretty easy as long as we have the same base. Then the rule was that we actually added the exponents. So remember, 2 to the 4th times 2 squared would then be equivalent to 2 to the 4 plus 2. You just add it, and that would be 2 to the 6th power. Okay, and then you can evaluate 2 to the 6th power being 64 by using your calculator. Okay, if it's just a variable, you have the same base. So the base in this case is x, and 3 plus 2 is 5. So this one would be x to the 5th. Okay, now if you have a mix, in this case we've got 4 and 2 are our two coefficients and we're multiplying them. We still multiply the actual numbers of the coefficients. So 4 times 2 is 8. But the x's, so now x squared times x to the 3rd, the rule is we add the exponents, so this would be x to the 5th. Okay, so if we simplify that expression, we would get 8x to the 5th. Now with D, we've got our coefficient, we've got 4 and then we've got 3, so let's multiply those and get 12. X would be to the 2 plus 3 would be to the 5th power. And your y, remember we have a little 1 right here, so it's really y to the 3rd power, okay? So that's a quick review of 4 examples of the product of powers property. On the next screen, I've got 4 examples, and I want you to pause the video right now and try these 4 examples, okay? And I'll give you a minute to do that. So pause here. And now you should be returning, okay, if you paused it. Now we're coming back and checking our work. This one should be 4 to the 3rd power, okay, 4 to the 3rd power when you evaluate it is 64, okay. Here we have a base of b, and 3 plus 6 is 9, so you should have b to the 9th, so let's circle these. Okay, for number 3, you're going to multiply the two coefficients and get 6, and your x is going to be to the 3 plus 2, which is 5. And then your 4th example, you should have 8. X times x to the 3rd would be, remember there's a 1 here, x to the 4th, and then your y would be to the 2 plus 4, which would be 6. Okay, so moving on to your next property, we had the power of a power property, and remember in that case you multiply the exponent inside the parentheses to the exponent on the outside. So 4 squared to the 3rd power would actually be equal to 4 to the 6th power. Okay, and then you can go ahead and evaluate that. X to the 3rd would be x to the 9th power. Okay, and this would be x to the 8th power because 4 times 2 is 8. And then your y would be to the 14th power. Okay, so you might want to go ahead and evaluate 4 to the 6th. Let me get my calculator out here. I don't have that right now, so I'll come back to that. All right, so looking at the examples, let's write these 4 down. Okay, pause the video right here and then go ahead and try these. Okay, all right, so welcome back. This would be x to the 12th power. 4 times 3 is 12. This one you'd have to take 2 as your base, and 2 would actually be to the 6th power because 3 times 2 is 6, and 2 to the 6th would be 64. Okay, and then your y would be to the 5 times 2, which would be your 10th power, and your x would be 6 times 7 is your 42. Okay, so there's your 4 answers there. All right, now moving on to the next property, we have power of a product property. So in this case, we have all the factors inside of the parentheses. You want to take each factor and raise it to the power. So in this case, you'd have x would be to the 2nd power, y would be to the 2nd power. Notice x is a factor and y is a factor. All right, our second example, if we take our first factor, which is a to the 3rd, and we raise it to the 3rd power, we're going to use the power to a power, and we get a to the 9th. And then b would be to the 6th. Okay, in the example for number 3, our first factor is 6, so we're actually going to square 6. X is going to be to the 4th power because 2 times 2 is 4, and y is to the 6th. Now we evaluate 6 squared, and we get 36, x to the 4th, y to the 6th. And that would be our answer. And number 4, we would get 9 squared, x to the 6th, and y would be squared. 9 squared is 81, x to the 6th, y squared. Okay, so write down these 4 problems, pause the video, and come back and check it. All right, so our first example, we'd have x to the 3rd, y to the 3rd. Second example, 2 would be to the 3rd, a would be to the 6th, b would be to the 12th. 2 to the 3rd would be 8. Our final answer, 8a to the 6th, b would be to the 12th. Okay, number 3, we would have 4 to the 3rd, x to the 6th, y to the 6th. 4 to the 3rd would be 64, x to the 6th, y to the 6th. And number 4, we would have 7 times 7 is 49, or we can say 7 squared, 49, a squared, b to the 6th. Okay. All right, so our next property is a negative exponents property. So if you have a negative exponent, remember it's equivalent to the reciprocal, and make the put the actual exponent in the denominator, or actually take the reciprocal. So if it's in the denominator, move it to the numerator. So in this case, x to the negative 4th power is actually equal to 1 over x to the 4th power. Okay. 2x to the negative 3. Now notice only the x is to the negative 3 power, so 2 would stay in the numerator and x to the 3rd would go to the denominator. Okay, so remember this is a review. All right, so here we've got 3 to the negative 2 power, x to the negative 2 power. So every factor gets raised to the negative 2 power, so we can start out and just write it like this. 3x squared like that. And then evaluate. 3 squared would be 9, and then x squared. Okay, and there's different ways you can do that. Okay, and then the example for D, only y is to the negative 3 power, so your final answer would be 4x, and then the denominator would be y to the 3rd. Okay, so pause your video right here, write down the 4 problems, and come back and we'll check them out. Okay, so welcome back. Here you should have 1 over b to the 3rd power. This should be 2 over x to the 4th power. Okay, I'm going to write this one as 1 over 2x squared y, and it's going to be to the 2nd power. Then I'm going to take each factor inside. 2 squared would be 4, x to the 4th, y squared. Okay, and then for number 4, everything is to the negative 2 power, so I'm going to start just by writing it like this. 3a to the 3rd, b to the negative 2, and that's squared. Okay, all right, so now when I evaluate, I've got 3 squared is 9, a to the 6th power, b would be to the negative 4 power, so then I can't have a negative exponent, so I'm going to bring the b to the negative 4, make it the reciprocal, so move it to the numerator, 9a to the 6th, and that would be your final answer. Okay, so the next rule is the easy one. Anything to the 0 power is equal to 1. Okay, so 6 to the 0 power is 1. X to the 0 power is 1. XY, because it's in parentheses, it's to the 0 power, so it's equal to 1. Now be careful with D here, because y to the 0 power, only the y is to the 0 power, so this would be x times 1, and that would be equal to just x. Whoops, let me write that. So x times 1 is just equal to x in that case. All right, so that's an example of the 0 exponent property. So pause the video here, write down the 4 problems, and then pause it, and now give it a try. All right, when you come back, you should have 4 to the 0 is 1, p to the 0 is 1, ab squared to the 0 power is 1, and x squared times y to the 0, so x squared times 1 would just be x squared. Okay, and then we have the quotient of powers property. So the rule says when you have the same base and you're dividing, you simply subtract the exponents, and it would be the numerator exponent minus the denominator exponent. So this would be 4 to the 3rd divided by 4 squared is 4 to the 3 minus 2, which is 1, and 4 to the 1 power is 4. Okay, this one we'd have the same base of x. 10 minus 3 is 7, so that would be x to the 7th. Okay, here we've got a couple of factors. So x squared divided by x would be equal to 2 minus 1 is just 1x. And then y to the 5th divided by y to the 6th is y to the 5 minus 6 is y to the negative 1. Well, our final answer can't have any negative exponents, so the final answer would have to be x divided by y. You'd simply move that to the denominator. Okay, and then don't forget when you have a coefficient, you're not subtracting, you're dividing. So this one would be 10 divided by 2 is 5. X to the 4th divided by x squared is x to the x squared. And then y to the 3rd divided by y to the 4th is y to the negative 1. Again, we write the final answer without a negative exponent, and it would look like this: 5x squared divided by y. Okay. Okay, so continuing, you want to write down the next 4 problems and then try them and pause the video. And as soon as you're done, continue. So I'll go over them right now. Welcome back. This would be 5 to the 6 minus 4 is 5 squared. That would be 25. Okay, x to the 9th divided by x squared would be x to the 7th. Okay, x to the 3rd divided by x would be x squared, because 3 minus 1 is 2. And then y squared divided by y to the 3rd would be y to the negative 1. And you would write your final answer as x squared divided by y to the 1st, or just y. Okay, so the last example, 9 divided by 3 is 3. X to the 4th divided by x squared would be x to the x squared, because 4 minus 2 is 2. And then y to the 1 divided by y squared would be y to the negative 1. So you would write your final answer as 3x squared divided by y. Okay, so moving on to the final property, the power of a quotient property. Okay, if you notice, we have a quotient and it's raised to a power. So you're going to then take the numerator, raise it to the power, and the denominator and raise it to the same power. Okay, so this would be equivalent to 1 squared divided by 2 squared, which would be 1 squared is 1 and 2 squared is 4. Okay, with b, we're going to take the numerator. X squared to the 2nd power would be x to the 4th, and the denominator, we take y to the 3 times 2 is 6. Okay, c, we would raise 2 to the 3rd power, x to the 3rd power. 3 would be to the 3rd power, and y would be to the 6th power. So when we simplify, we're going to get 8 to 2 to the 3rd power is 8, x to the 3rd divided by 3 squared is 9, y to the 6th. Squeeze that in. Okay, and then always make sure, in this case, 8/9 is reduced. Okay, it might need to be simplified, but in this case, it's already done. Okay, so D, we're going to take 4, we're going to square it. A is going to be to the 4th, B is going to be squared. Divided by, we're doing to the denominator, 2 would be to the power of 2, and A would be to the power of 2. Okay, so 4 squared is 16. A to the 4th b squared, and then we're going to divide by 4a squared. Our final answer would be 16 divided by 4 is 4. A to the 4th divided by a squared would be a to the 2nd, and then b to the 2nd. That would be our final answer. Okay, so go ahead and try the next 4 problems, okay, and then come back. All right, this would be 3 squared over 4 squared, which would be 9/16. Okay, number 2 would be x squared y squared divided by 4 squared, which would be 16. 3 would be 36 a to the 4th power b squared all over 3 squared, which is 9b squared. Okay, 36/9, we can actually divide by 36/9 is 4, so 4 a to the 4th, and b squared divided by b squared is just 1, so they would cancel out. So our final answer would be 4a to the 4th power. Okay, and the last one, we've got x would be to the 4th power, y would be to the 2nd power, 3 would be to the 2nd power, so 9 x squared y squared. Okay, and then when we simplify, we're going to get x to the 4th divided by x squared, so we subtract, that would be x squared. The y squareds would cancel out, and we're left with 9. So x to the 4th, so it would just be x squared divided by 9. Okay, so that's it for now. We're going to be doing some of these review lessons, and then you guys can practice different problems, and then eventually we'll be getting into new material. Okay, so feel free to email any questions. Bye-bye.